Welcome to another video lesson. In today's video, we're going to be talking about yet another shape and finding the area of trapezoids, lesson 9.3. You're going to need that blue sheet, and again, just like the previous lesson, fold it in half like a book and fill out your table of contents. I'm on page 92. We're just going to title it Area of a Trapezoid. Now, a trapezoid's definition is in your vocabulary sheet, so you can refer to that. Also, I have an example here of the definition. A quadrilateral, four-sided figure, is a trapezoid, but the important part of a trapezoid is that it has one pair of parallel sides, and the parallel sides are called the bases, and the non-parallel sides are called the legs. So here we have a trapezoid. Again, we have the arrows. These two lines are parallel to each other, therefore they are the bases of the trapezoid, and these are not parallel, so they are called the legs. There are actually different kinds of trapezoids, and on the top of your blue book on the front cover, you have three pictures. We're going to label each one of them. The first one is an isosceles trapezoid, so go ahead and fill that in. I also would like you to note that these two legs happen to be the same length. These are the legs because they are not parallel. They will eventually cross somewhere up here. And you see the two arrows on the bases, they are parallel. First kind, isosceles trapezoid. The next one is what's known as a right trapezoid. It has two right angles. It's like they took a rectangle and they kind of just sliced it on the top and left the rest of the rectangle intact. So the big thing here is that these have right angles. It's a different kind of trapezoid. Usually you're used to seeing the isosceles trapezoid, and sometimes you forget that the trapezoid can look different ways. The third trapezoid is called a scalene trapezoid, and that is because all of these sides are different lengths. Just like a scalene triangle has all the sides different lengths, a scalene trapezoid has different lengths for all of its sides. So this leg is different than this leg. This base is a different length than this base. So you can go ahead and put those hash marks in, fill in the names of the trapezoids, and then we'll move on. The first thing I wanted to talk about regarding a trapezoid is this idea of deconstructing. Construction, or to construct, is in the word deconstructing. If you're building a house, that means you're in the process of constructing it, or the construction that goes about building a house is usually what happens. However, sometimes we have to tear houses down, demolition, that kind of thing, and that's called deconstructing, breaking something down. So you have this definition in your book already. Deconstructing is breaking down a shape into smaller shapes that then you can work with. So we can look at this trapezoid as having two triangles and one rectangle. We're going to find the area of the rectangle. That is going to be length times width. The length of the rectangle is 6 inches. The width is 5 inches. So when we plug and plop, just really quickly, we have 30 inches squared for the rectangle piece. So I'm just going to label that 30 in here. The triangles are both the same. And I know that because these are the same length. This is an isosceles trapezoid, so I can just find the area of one of these triangles and then double it. So the dimensions we need is the base, so that's going to be our 3. This dotted line that was the width for the rectangle is also the height for the triangle. So now we're going to have 1/2 the base times the height. For our formula from the last lesson, we have the base of 3 and the height of 5, which is 15, that we have to take half of. When we do, we get that each piece is going to be 7.5. So this guy is 7.5, this guy is 7.5, and then once we find the area of all the pieces, we have to put them back together and construct the trapezoid. So we will have 30 and then the two triangles, which are each 7.5. So this is 15 plus 30. The whole thing will be 45 inches squared. So I know there wasn't a whole lot of room to do that. Hopefully you found some room around the trapezoid and around that word deconstructing. And that is one way that you can find area of a trapezoid. Besides deconstruction, we can actually use a specific formula for trapezoids. In order to show you how we came up with the formula, I'm going to do a little demonstration that you have pictures of right below where we were deconstructing. So if you remember these pattern blocks, this is an isosceles trapezoid. What the cool thing about two trapezoids is if I have another one that's exactly the same, I can actually flip it over and put it together with the, whoops. So if I have two isosceles trapezoids, I can actually put them together like a puzzle piece and literally make a parallelogram. So you see that picture actually on your notes right here. And what happens is that the top of the trapezoid then becomes the bottom of the trapezoid that's to the left or right of it, and vice versa. So you have a long parallelogram where the base of the parallelogram is composed of the bottom base of the trapezoid and the top base of the trapezoid. And the height stays the same. Another way of talking about it is with the right trapezoid. So if you have the right trapezoid, you can make an identical one and you can literally turn it so that the top and bottom are flipped over and you will get a parallelogram, which is the second picture that you see. So you can, just like putting two triangles together to make a parallelogram, you can put two trapezoids together to make a parallelogram or a rectangle, depending on the trapezoid's type. Why I'm showing you these is so that the formula makes a little more sense to us. If we counted this first part of the top of the trapezoid, it's 6 units, and the bottom is 10 units. If then we turned the trapezoid and put it on the other end, we would have the 6 units down here and the 10 units up here. Now we can easily find out, hey, what's the total length of this base of the parallelogram? The base is going to be 16, and the height stays the same. It's this distance that's perpendicular to the base, and the height is 5. So if we were to multiply, area equals base times height would be multiplying that 16 by 5. So the area of the whole parallelogram will be 80 units. But just like with the triangles, we only want to know what the area of a trapezoid is. So we have to cut it in half, just like we did yesterday. So the area of the trapezoid is going to be the 80 cut in half, or the 40 units squared. Now let's talk briefly about this one. We have the top of this trapezoid is 3 units. The bottom is 5 units. So this is now 5 units, and this is 3 units. We have to combine the 3 and the 5 to get the length of the rectangle, which is 8 units. And the height is just the 3 units. So this is the height. We can find the area of the whole rectangle by multiplying the length of 8 times the height, which is 24 units. But again, we're not wanting to find the area of the rectangle. We want to find just one trapezoid, half of that shape. So for the area of the trapezoid, we're going to take 24 and cut it in half, which will be 12 units squared. Hopefully now, when I show you the formula, it'll make more sense. We're going to take the area of the parallelogram we've made by combining two trapezoids and then cut it in half at the end. So because of our work with our trapezoids and combining them to make bigger shapes, we can find the area of a trapezoid with a formula taking 1/2 the product of the height and the sum of the bases. And the bases are going to be labeled base 1 and base 2, as you've seen in our pictures. The top base is B1, the bottom base is B2. And as you saw when I turned those, we had to add the 10 and the 6. We had to add the 5 and the 3. So that's why we're adding the bases together. That's duplicating our trapezoids, turning it and making it into a big parallelogram. And then we're gonna have to take half later. Formula can be written with a fraction, just like our triangle formula. And we're going to multiply it by the height. And then we're gonna have a set of parentheses so that we can add our bases before we start to multiply. That's important. We also can write it as the fraction form, and that is just having the h being multiplied by the sum of the bases, and then at the end dividing it by 2. I usually use the fraction one. Again, either one is fine though. One final note before we try some examples, that a trapezoid has two bases, B1 and B2, and these two bases are parallel. There will always be the same distance apart. That ends up being the h. The height of the trapezoid is the perpendicular distance between the bases. So on the inside, there's actually 3 on the left and 3 on the right. I'm only going to do the first 2 on the left and the first 2 on the right, and I'm going to save the bottom number 3 and 6 for you to try on your own. So number 1 looks like this. First thing we have to do is identify what pieces we see. The top of the trapezoid is B1, the bottom is B2. The perpendicular right angle symbol is here, and it is touching the 7. This is the height. And one of the bases is 12, one of the bases is 5. So now we're going to do our formula. This is a more complicated formula, so I want you to get used to writing it 1/2 times h times the sum of the two bases. We don't know the area. We know that we have to take half, and now we get to pluck and plop out our h. The h is 7, and then our two bases are 5 and 12. It's very important that we add first, and then we can multiply in any way we want. So 5 and 12 is 17, and now we have a 7 and a 1/2, and we're multiplying all of them. At this point, you can take your calculator, take half of 7, that would be 3.5, and then multiply that by 17. When we do, we get 59.5. Remember, our inches squared is our unit to end things off. Here's number 2. I'll walk you through this one as well. Labeling first. We have our two bases, which are these parallel lines. So we have B1 is 11, B2 is 14. Our right angle symbol is here, referring to this dashed red line. So our 8 is our h. Let's write the formula. A equals, I'm going to use the fraction form just so you can see how that is used. So we have h times the sum of the bases, and then dividing it by 2. Now let's plug in our numbers. The h is 8. Our bases are 11 and 14. I have to add that up first. That's going to be 25. Now we have a couple of different options here. I would multiply the numerators first and then divide by 2. So we have A is going to be 200, and then we divide that by 2. I'm running out of a little room, so I'll come up here, and A is going to be 100 with our unit of centimeters squared. If you wanted to simplify this 8 and 2 by dividing, that would be fine as well, and then you would just multiply 4 by 25 to get 100. Go ahead and try the bottom one on your own, and then I'll show you the answer all done so that you can check to see if you were right. Here's the answer to number 3. At this point, I chose to divide 9.8 by 2 first. You can use a calculator for these computations. Now, we've done missing dimensions for parallelograms and triangles. We are going to do missing dimension for trapezoid, but we are only going to be finding the height. If we're given the area, we'll be asked to find the height. This is the formula for height, and tomorrow in class I can show you if you're interested on how did we get this formula. We started with the area formula for a trapezoid, and we manipulated it to find h on one side, and what do we have to do in order to get h. So this is already in your notebook. On that right-hand side, right up in the corner, draw a cloud around that, and we'll practice with a couple, and then you'll try one. So the area of the first one is 108. The bases are the only thing that we are given. The base 2 is 15, and the base 1 is 12. We have to find the height. So our new formula is going to be h equals, we're going to double the area, and then divide it by the sum of those bases. So let's fill in what we know. Our height, we don't know. We're going to double the area, which is 108. And then we have to take our 12 and our 15 and add them up first. When we do that, we get 27 and 216. 216 divided by 27, you could do it by hand or grab a calculator. It ends up being just 8. Remember, with height and missing dimensions, we just want feet as our unit. Let's try another one. The last two don't actually have pictures. It literally just lists out what we need to plop in. So there's no labeling of a picture. We just can start with our formula. H equals, we're going to double the area and then divide by the sum of our base 1 and base 2. Our H is going to be doubling 21 and then taking our 2 and our 5, adding them up. So doubling 21 is 42. Adding 2 and 5 is 7. 42 divided by 7, we can do that in our head, is 6. Our unit is yards. There we go. You have one more to try. No picture, so just use the formula, pluck and plop and solve. Come back and see if you're right, and it will be done. So here we have the formula that we started with. We plucked and plopped. We multiplied and added, and then divided to get 3 centimeters for our height for our last one. Look forward to working with trapezoids more with you tomorrow. Have a great night.